Friends, now we are going to discuss about preparation methods of alkanes. Part 2. The first part, we did preparations of alkanes by the reduction of alkenes, alkynes and from alkyl halides. Now, in this part, we are going to do about preparations of alkanes by the reduction of alcohols, aldehydes, ketones, carboxylic acids and acid derivatives, acid halides and amides. Right, let's start. Here, from alcohols, how to prepare alkanes. So, take here the fourth one, that is alcohol formula ROH. ROH, when it is react with reducing agent, that is HI, the presence of red phosphorus, and it is heated about 150 to 200 degrees Celsius temperature. At this temperature, what happened here? This hydrogen and hydrogen iodine bond undergoes cleavage, and here this alkyl group oxygen bond undergoes breakup here. So this bond breakup, okay. Then to this alkyl group, one hydrogen is added. To the oxygen atom, one hydrogen is added, right? Then how many hydrogens are added? Two hydrogens. Then it is removed as RH. That is alkane will get, and this is removed as H2O. H2O, right. Then this iodine, it is removed as I2, right. Next one, from aldehydes. The aldehydes general formula RCHO. Aldehydes general formula RCHO or C double bond OH. RCHO. It is also undergoes reduction by the use of HI and red phosphorus at the same conditions, 150 to 200 degrees Celsius temperature. Now what happened here? It is a reducing agent. It reduces, what is reducing agent? Which reduces neighboring substance. Okay. So reduction means what? Addition of hydrogen. Addition of hydrogen, removal of oxygen. You have to add hydrogen. So you have to remove oxygen atom. Here carbon oxygen, two bonds are there. First bond you have to break it here. By the breaking of this bond, to this carbon atom, one hydrogen you have to add it. To the oxygen atom, we have to add one hydrogen. The next bond also have to break it. With the breaking of the second bond, to the carbon you have to add one hydrogen. To the oxygen you have to add one hydrogen. Then it is removed as water molecule, right? Now RCH3, there is a alkane will get RCH3, and it is totally how many moles of hydrogens we are required here? We use it here 1, 2, 3, 4. There is 4 moles of hydrogen. So then it is removed as H2O, and then iodine, there is 2 moles of I2, 2 to 4 iodine. Right? Got it. Next one, from ketones. So ketones general formula, that is RC double bond OR, right? RCOR undergoes reduction by the use of HI and red phosphorus at 150 to 200 degrees Celsius temperature. Here what happened here? So the reduction means in the presence of this reducing agent here, the CO bond undergoes cleavage. So carbon oxygen bond. So that's simply here, this bond undergoes breakup. To the oxygen atom, one hydrogen is added. To the carbon atom, one hydrogen is added, right? Next bond also you have to break it. Carbon oxygen bond. Then to the oxygen, one hydrogen you have to add it. To the carbon, one hydrogen you have to add it. Okay. So then, so this one bond is replaced by 2 sigma bonds, right? Yeah. Then it is removed as H2O. Then you will get RCH2R. It is a alkane, you will get RCH2R alkane. Alkane will get, right? And this is removed as H2O. Then how many moles of hydrogen we required here? 1, 2, 3, 4. There is 4 moles of HI. 4 moles of HI, right? Then it is removed as I2. How many moles? 2 moles of I2, right? Okay. Next one is from carboxylic acid. From carboxylic acid, that is RCOOH, carboxylic acid, right? It is also undergoes reduction by the use of HI and red phosphorus at 200 degrees Celsius temperature. Then what happened here? Here also the carbon oxygen bond, wherever oxygen is there, you have to remove it, you have to eliminate it, and you have to add hydrogen, right? That is reduction. That is called hydrogenation, right? So here carbon oxygen bond, you have to break it, and to the oxygen one hydrogen, to this carbon one hydrogen. Then here this carbon oxygen bond also have to break up, to the oxygen one hydrogen, to this carbon one hydrogen you have to add it, right? Then this is, and here one carbon oxygen bond is there, this bond also have to break it, this bond also have to break it, right? This carbon oxygen bond to this oxygen one hydrogen, and to the carbon atom one hydrogen you have to add it. Then it is removes as H2O, it is removes as H2O, and it is also removes as H2O. Then you will get, or CH3 you will get, or CH3 you will get, or CH3, alkane you will get, alkane you will get, right? And this is 2 moles of H2O, 2 moles of H2O, and then this is totally how many moles of hydrogen we use here? This is 1, 2, 3, 4, 5, 6. So 6 moles of hydrogen, that is removes as 3 moles of I2, 3 moles of I2, right? 3 moles of I2, okay, right. Next one is from acid halides formula RCOX, that is X will be a chlorine, bromine, iodine, right? We will say chlorine to take acid chloride, ARCOCl, acid chloride, right? So it is also undergoes reduction by the use of HI and red phosphorus at the same conditions, that is 150 degrees Celsius to 200 degrees Celsius temperature. Then what happened here also, right? Here also what you will get, that is here the same thing, carbon oxygen bond undergoes break up. Here to the oxygen one hydrogen you have to add it, to the carbon one hydrogen you have to add it, and this second bond also have to cleave it, to the oxygen one hydrogen you have to add it, and to the carbon one hydrogen you have to add it. Then this carbon chlorine bond is there. So this is carbon chlorine bond is there. You have to remove this chlorine also. Actually, removal of high electronegative element is called what? Reduction. It may be oxygen or maybe chlorine also, right? So chlorine is high electronegative element. You have to remove it and you have to add hydrogen. So by the break of carbon chlorine bond, to the chlorine one hydrogen you have to add it, and to this carbon one hydrogen you have to add it. Then you will get, it is removes as HCl, and this is removes as water, right? Then you get, or CH3 you will get, or CH3 you will get, or CH3 you will get, that is alkane you will get, and this is removes as H2O. And then how many moles of hydrogen we used here? 1, 2, 3, 4, 5 and 6. Totally 6 moles of HI. That means it is removes as 3 moles of H2, 3 moles of I2, 3 moles of I2, 3 moles of 6, and this is HCl. This is HCl is also reason, right? Next one, there is acid amides. Acid amides. So acid amides, you can represent, that is here RCONH2, RCONH2, okay. Acid amide, you just represent here acid amides, okay. Okay, my dear students, up to here you got it, okay? Yeah, up to here you got it, right? So acid halide, we did know acid amide. Acid amide we just represent here. Acid amide, only one equation. So by reduction methods we did it in sequence, it is there, right? Acid amide formula, this is 9th one. Acid amide formula RCONH2, acid amide, right? Okay, so it is reduced by HI, the presence of red phosphorus and heated at 200 degrees Celsius temperature. Then what happened? What you will get? Here, reduction, you have to break it here, the carbon oxygen bond, this bond, and to the oxygen one hydrogen, to the carbon one hydrogen you have to add it. And next, you have to break it, this carbon oxygen bond also, to the oxygen one hydrogen, to the carbon one hydrogen you have to add it. And here carbon nitrogen bond is there. So nitrogen is a high electronegative. You have to break this bond also, and to this nitrogen one hydrogen I have to add it. So same CN bond, carbon nitrogen bond, by breaking that, to the nitrogen atom one hydrogen you have to add it, and to the carbon atom one hydrogen you have to add it. Then it is removed as RCH3. And so what is removed here? This is NH3, this is removed as NH3, and this is removed as H2O, right? You get RCH3, you get RCH3, and it is removed as H2O, and this is there is how many moles of hydrogens we required? See, this is 1, 2, 3, 4, 5, 6, right. Totally 6 moles of HI is required. 6 moles of HI is required, right. So that means this removes as 3 moles of I2 and then this is removes as NH3. NH3, 3 moles of I2 and NH3 is also removed, right. NH3. Okay, got it? Is it clear? Fine. Okay, my dear students. So this is the methods of preparation of alkanes by reduction of all these functional group compounds. Okay, is it clear? I think you enjoyed my video. Right one. Fine. So some more methods are there. There is preparation of alkanes by decarboxylation of salts of carboxylic acids and coal-based electrolysis methods and ROH reaction, Franklin reaction are there. So that will do the next part, part 3. Okay. So please watch first part and the second part of that. The continuation I will give to you all concepts clearly. You can easily grasp it and you can definitely increase your score. Okay. So fine man. So now like it, subscribe it and share to your friends. Thanks for watching my video. Fine.